everyone. I am Scott King, and that is Chris Kraus. Thanks for joining us at this episode of the Union Podcast, where we're gonna talk about AI, and we're gonna talk about the hype versus the reality, because the hype around generative AI, Chris, it's great, right? It's tactically valuable. People can use it, but there's more value, there's more models in other types of AI, right? So that's explain a little bit about what we're going to talk about in terms of, one, yes, there's the hype and everyone's trying to get on board, but you may be missing an easier and simpler opportunity.
Right. So we talked about this. If you don't remember the types of AI that are out there, there's natural language processing and understanding. There's categorizers that allow you to pick things, like categorizing is basically like in an email. Is this email for a question on returns? Is this email a question on order statuses? Or categorizing can be like picking something from a list, like, should this customer get a discount? Yes or no. You're picking from a list. Another one is predictors, and predictors, which is kind of weird because you think of, I'm going to predict a category, but I'll try to be very specific with my words. Predictors are, you're predicting a number. So an example that like John Michelson always gives is, there's a way to convert from Celsius to Fahrenheit. There's a mathematical equation to do that. But in a predictor and machine learning, you give examples of both, and then it figures out what it should be. Like, what should be the temperature be? Or if you want to predict, say, maybe your electric consumption, electric companies, they do this. They may look at the temperature. They look to say, is there a holiday in the week? So you're going to be home versus at work, to see if your usage patterns change. And they predict what your electric consumption should be in your bill. So you're predicting a number. So these two things have been around a very long time. They don't have the hype of generative AI, so it's kind of overshadowing it. It's definitely raised our expectations. But there's other things we can do with machine learning models in the realm of AI that have great value, especially to the enterprise.
So, yeah, John always talks about there's greater value in predicting numbers and dates, right? Because those are helping, maybe financial decisions or something like that. And we attended it was just a generative AI summit, so it was kind of focused on that. And there was a guy from E&Y, Oscar Marine, and he agreed. He said the predictors are way more valuable. Generative AI does have some value, and this was I think it was at a law firm, wasn't it, Chris? And they were talking about generating contracts and doing more paperwork. I mean, that saved time, but it didn't really move the needle on a balance sheet.
Mm-hmm.
All right, so if we're going to talk about predictors or categorizers, what are they doing? So maybe explain what they are and then how people are using those today, because I would imagine it's simple, not simple.
It depends on your perspective, right? So there are a lot of open source models, machine learning models. So the math, if you need a refresher on that, we did a blog on what's AI, how does machine learning work in all the categories. So if you want details, I'll keep it higher level here. But machine learning is a mathematical model, and a predictor is basically, say, giving me different, say, numbers or attributes, and then predicting a number. So for example, the electric consumption in your house could be based on temperature. You may want to know the humidity, then how many days that you would be in the home versus at work. And then you would give sample history of that to a machine learning model. And then it would start predicting how much electricity you would use. So you say, historically, over the last 12 months, this was the temperature, the humidity, what Monday through Friday were holidays or not, and then the electric consumption. And then we say, okay, machine learning model, based on this historical data, let's predict in the future. If it's this, the weather forecast is this, and there's a holiday, not a holiday, let's predict how much electricity we'd use.
Can ERCOT use this? Because they seem to mess this up.
Yeah. So ERCOT and like our local provider Encore, they do this, right? I get from my electric bill, whether you've got like, you know, Tri Energy or Green Mountain, whatever, you get these predictions, and it's based on looking at weather patterns in that. Um, so categorizers, that's one that people kind of get, especially when you talk about email. It's like, let's categorize this email. Is this the intent is to answer a question about an invoice or a bill or an FAQ. It could be applied into, say, giving someone vacation leave. Like when a manager is asked, can I take vacation? They're going to look at some different data. They're going to look at, okay, how much vacation is available for this employee? Do they need an override? Maybe they work in a warehouse, so they want to know how many people are on shift, how busy is the warehouse from the forecasting engine, and then they're going to say, yes or no, I have enough people, I can grant vacation or not. So that's like a yes or no answer and a categorization.
And
So
unless your manager is mad at you and introduces bias into the equation,
yes,
right?
well, you would learn the bias, right?
Yeah.
Yes, you definitely learn the bias. And so the idea is there's lots of like machine learning models out there. So if you get a textbook on machine learning, or you go to one of these websites that talks about machine learning and that, they'll tell you there's pre-built models out there. They're open source that have the mathematical equations to do calculations of a number and predictions of a category. And so there's different clustering analyses and that. But so that's all there. Now the trick is you would have to learn to be a data scientist. You don't probably have to learn Python and open up PyCharm and download scikit-learn, and you'd actually have to start learning how to be a data scientist to use these. So
yeah, that was my next question: is who's doing this? Because I would assume if there's an open source model, right, that's automatically, way more technical than I think most people on the internet,
Yes.
right? Because people can people can use Chat GPT, right? It's basically the machine learning that has like a nice user interface. But what you're talking about is the models back behind. So you have to be a data scientist, I would assume, and then
and a programmer.
yeah, and there's a finite number of those people, right?
Right.
So we have to bridge that gap between what's an open source model and how to make it usable.
Yeah, and a programmer can use them. A data scientist has learned that these models do categorizations and clustering of data one way versus the other way. These do predictions that handle time series data. These ones do predictions that don't handle time series data. So all of a sudden, the data scientist has like some intellectual property, some understanding of, okay, based on my problem, I'm going to look at my data, which we'll talk about next. I need to use this model or this model, or I need to try these two models or try these three models to actually solve the problem. So it's definitely a human process, a human thought, trial and error to find the right one. So now, of course, this is like 30% of the problems you have. This is like, there are 30% of the things you'd want to do. We believe there are already pre-built models. You start applying them and testing them. Of course, all the other ones, there's the multi-year data scientist, unstructured versus structured learning projects where you're doing all this stuff to really solve amazingly complicated things and write a new machine learning model. We're talking about the other use case, that 30%.
Yeah, I mean the complicated ones, that's what you're talking about when people are building businesses on top of AI products. We're just talking about like how to help everyday people make better decisions, right? So
Right.
we're not talking Netflix how to show the next title, based on your viewing history.
Right. And so in this case, let's go pick the model, and it's going to be based on the data. So ideally, you have some clean data. The data scientists can see, is it skewed? Is this time series data and such? They'll analyze that and they'll start saying, okay, which model solves this best? And then they actually start writing code to test them, right? So the problem is when you need a technical person to do that at the enterprise level, if you have 100 projects to do this, you're going to say, okay, I need to stack rank these on value. And then I need to ask the data scientist the level of effort to implement these. And then I may need a data scientist team to actually even though they're open source models, deploy them, test them, bring them up. And then how do I bring it to the customer? Like, how do I actually put this inside an application or workflow so people can use it? So that's where people kind of they get stuck. They're like, okay, there's just too many things that have to happen. This is actually a software development lifecycle to do
Yeah,
this.
how long? That sounds like a long time. Like, guesstimate how long is that you just explained?
So, like software development life cycles usually are like when we do big room planning and Agile, they're always like 3 months, 6 months, 9 months, those type of things together. It's a multi-month opportunity,
Yeah.
right? So at Krista, we say there is a better answer, like because I'm scoping to that 30% of the problems. We know there's open source models out there who know how to do these calculations. The trick is, how can you make the software or the machine do the work to pick the right model and run the tests for you? So you want to actually, that's kind of that people say machine speed. How can you actually get to a point where the machine is doing the work for you versus needing data scientists? Because you want those guys to solve those really complex problems where they're writing a model, not the things that we learn in school of like, here's 4 models, test them and tell me the differences, right?
So when in that scenario, does this data scientist does he help with this project? If we're going to help them, stick with the more complicated things and produce, that type of value with the more complicated models, this project that you're talking about, so it's less technical, right? Because I'm making the machine do all the testing and everything. But I would assume that someone wanting to run this test may or may not have good or clean data, right? So
Yeah.
a lot of the time they say the data science projects, the data is the biggest problem, right? So it's a whole lot of manipulation. Yeah. What about the data? Like if I don't have data, what do I do?
Yeah. So the 2 problems you brought up is the audience. We want to make this easier so that the business people can actually add this to a process without having data scientists. So that's where we want software to do the work. Think machine learning, building machine learning. And the business people actually know their data, right? So they can extract, say, out of their contact center information, emails and categories of what they were. Or they may have examples of data they can provide, like on giving discounts or not giving discounts to a customer, or like electric consumption. So the closer you get to actual functional business people, they actually know their data and they have their data. Now, of course, not all data is perfect, but if you have 10,000 emails and 3 are miscategorized, it's not going to skew the model. If 2% miscategorized, it's not going to skew the model. So you have to trust that the model's going to learn on the things that are more repeatable. But the closer you get to data, the closer you get to the business, the closer you are to the data itself. And then 2 things happen. Either you have some data to start with or you have none. So in the example of email triage, you probably have sample emails that categorized. And of course, you're going to say this isn't perfect because humans categorized it.
So when you say the sample emails, Chris, I can get that out of if I have a ticketing system or CRM
Zendesk,
system or
NetSuite,
something. Okay.
Salesforce. Yeah, I can go extract that and look at it.
Okay.
I probably put it somewhere. Now, on the other side, say granting vacation, this is a whole new process, right? So you may not have the data, but that doesn't mean you can't do it. What you want is the business people who are running this process to train the model in real time. So what happens is if we create, say, a workflow that says, okay, and the person says, I want to take vacation on these dates. And in the background, we go to the HR system and say, this is how much vacation the person has. We then look into success factors and say, okay, this is their manager. We figure out what warehouse they're working in. And then for that time frame, we ask the forecasting engine what's expected busy inside of there. We ask timesheets, how many people are on shift. That's all the data we would give to a human to make that decision. That's the same data we're going to give to a machine learning model to learn how to make this decision. So the idea is you can actually start with no data. Now, the AI model will have no confidence that it's the right answer because it's actually kind of in learning mode. And in this case, there's very little difference between training and retraining because it's done through the same experience, right? So we tell a human and don't tell them the AI answer. Given this information, would you grant vacation, yes or no? And then we give that as training data to the machine learning model. And then say after a month or two, and people who've had 200 or 300 people request vacations, it can then say, okay, I have some data. Let me create a model automatically. And in the background, it may run this through multiple categorizers, like random forest, and how does it do the clustering and things like that. It can run through multiple algorithms and then start giving you a prediction. So now initially those predictions may be low confidence if the data is very varied, or maybe they're kind of moderate confident because the questions are very similar, the profile of the amount of vacation and the shipping is all very similar. And so it allows you to start training while you're using it. So it doesn't mean you have to do that ahead of time. Implement your business process and then have that happen in the background. Then it's how do you get the users to trust it? The thing I mentioned on confidence, right?
Yeah, because the trust factor is big, right? Because you explained a process that a manager would go through anyway, looking in all these different systems and, like coming up with a yes or no answer, right?
Yes.
I mean, people are used to having their people do that, and moving that to a machine. There's just so many unknowns, like people don't trust it, right? But basically they're doing the same exact thing.
Right.
It's kind of interesting how you talk here. If there was no data inside this process and you basically, I'll say listen on the wire. I mean, you can think of like eavesdropping and just like building this data,
Yep.
like maybe row after row, right, in a table. I mean, that seems like a good way to do it, but you'd still want someone at the end of the process to push a button that says yes or no.
Yep. Yeah. And you do. And the idea is you're actually now, say, creating the data and the answers kind of in a curated way. So you have good data coming in. You've got your managers who are qualified to make the decision or making the decisions. And the AI model starts to learn how to categorize that. And it should say yes or no. So now what happens is, say after this runs for a couple months and we have the samples, you can actually modify your workflow just a little bit and say, okay, hey user, machine learning model has predicted yes, grant vacation, or no, don't grant vacation. And it'll give you a confidence. How confident it is in its answer. And that way the users will start seeing, okay, it's actually making a decision, and is it matching my decision? So the user at that point, you want them to say, yes, I agree, or no, you got it wrong. So what happens is we'll start walking them into the process to see, okay, this is what AI said. Do you agree or not? And what happens is the more they agree, the more the human learns to trust, okay, it's getting the right thing. Or the more they disagree, the more the model gets retrained and gets stronger over time. So it'll actually go from not agreeing to more agreeing. And at that point, we say, humans, like we all want some assistance. So if literally it is always getting the answer right, we can say, okay, I trust the AI is working. Let me handshake it. So it's not a black box. They actually saw it get better over time and notice it always agrees with the predictions, whether it's predicting number or categorizations. And then that means you would want to hand it over to automate that process so you don't have that manual effort on your side. And our assertion is you've got hundreds of these type processes in your business. If you just knew that you could do that, and 30% of those are going to be things that machine learning can build the machine learning. Like we have models today.
So, I mean, if this 30% example, we talked about the vacation policy. We talked about the email triage. We have a few customers doing that, and that saves a ton of time and effort. What are some of the other 30% examples that we can provide?
I mean, so I know that like when I've been on the phone with companies, like, do we give you a discount to keep you as a customer to prevent from churning? So if you're looking at moving off of your streaming service or your TV service or you're switching phone companies, they would look at you and say, okay, you a high value customer. should we give you a discount to prevent you from churning? So it's something like that could help in that, because that's always like, let me put you on hold and ask my manager, ask a person who's qualified to make the decision, come back, put that in the hands of every person answering the questions, right? Or like when I got my new iPhone, it said, well, you've had yours for so long on your auto replacement plan, so it's actually a hard-coded rule. If you're halfway through, yes, you get the new phone. If not, you have to wait this many months so you're halfway through. Well, that could actually be more subjective based on how huge your phone bill is, right? Machine learning, it didn't have to be a hard and fast rule. So think about if there's things you have hard and fast, if contract greater than 50% of months, yes or no. Do you want to add some flexibility there?
Yeah, I bought something from this website a couple of different times, and they have a hard rule. If you put something in your cart and you close your browser, they immediately email you a 5% discount for your cart, right? So I just get 5% every time because I'll just build my cart and then close it. Then they email me, right?
Yeah.
So it's ridiculous, but I do it anyway.
Yeah.
Because it's quite expensive, right? But the AI rules, it's a whole different ball game. But it's not as simple. It's simple. It's not as hard as people think it is.
Right.
So from a takeaway, Chris, what do people need to do? Like how could they get started to say, okay, I still don't trust you, but if I was going to do one of these higher volume, lower risk, situations with the predictors and the categorizers, what do they need to do?
Okay. So I would say first thing is go look at your business case to say, okay, is this something that happens every day, 100 times a day? Because things you want to spend some effort on, things that are high volume that you do all the time, you actually want to automate because then you get more value for your bang for your buck, right? And the second is, if you can think through the process, okay, what is the different input data I need to make this decision? And then what is the output decision? Is it predicting a number or is it categorizing, picking something? Then you can actually contact us and we can help you with that. That's because the machine learning models are built automatically in the software. All you do is you give us, say, like Excel or a CSV file of the actual data and then the answer you're expecting. We run it through the software and it says, okay, I've picked a machine learning model for you. Don't worry about what it is. And we'll tell you how confident we are. We'll take 80% and train and take 20% and test, which is what happens in the background. And we'll test them and say, okay, this is actually what we're predicting. So it's, in most cases, it's not, can the machine learning help me? It's like, am I ready to make that change? And then is this a big enough pain? Does it happen often enough that I want to automate it? And so, and they exist, right? They exist. And there's lots of machine learning models that can solve this, but it's actually that operationalizing them. And that's something we can totally help you with.
All right. Well, that makes sense. All right. I appreciate it, Chris. And I like what you said. Am I ready for this? So, so that may be the title. So that's pretty interesting. Well, thanks for joining me for this episode of the Union Podcast, Chris. I really enjoyed this episode. It was interesting because it's a little outside of my world. And until next time.